going to do what's called the quadratic formula, and I actually on that warm-up handout that you did, the back side of that is the first couple, or actually this first page is there, so you have the this information. So in the previous lessons we completed the square to solve quadratic equations. If you complete the square of ax squared plus bx plus c equals 0, you can actually derive what's called the quadratic formula. So the quadratic formula is the only method that can be used to solve any quadratic equation. Okay? So anytime we ask you to solve a quadratic equation, the quadratic formula is one method that will always work. Completing the square will too. Sometimes it gets a little bit more difficult when you start working with fractions. Factoring doesn't always work because everything's not factorable. Graphing and tables don't always give you exact values. They can give you approximate, but not always exact ones. And so we've dealt with the 5 different methods now, and this is the last one. All right, so we did graph tables, we factored, we did square roots, we did completing the square, and now we're going to do what's called the quadratic formula. And so one of the things that you're going to want to put on your note card is the quadratic formula. And I'm going to actually write it in a different method. I like this method is okay the way that the book sets it up. It's funny, the smart board does it that way too. But when I do it, I actually prefer to do it this way. And what I do is just break this into 2 fractions. Now, both of them have their good and their bad. All right. One is the way that it's here in your book is that it's harder to simplify when it's in that form. And with pulling it apart like I do, what happens is that sometimes people forget that this fraction bar goes all the way across, and they'll take what's under the radical and divide by 2 times whatever a. They'll just go ahead and do that division, and you can't do that because it's the one part's in the radical, the denominator is not in the radical. Okay. But I like this also because here's negative p over 2a. What does that tell me? What's negative b over 2a tell me with a quadratic equation or quadratic function? Okay. What, Michael? Okay, the axis of symmetry. All right. So what happens is that the axis of symmetry, if you remember, that cuts the graph in half. And so then this part here, the square root of b squared minus 4ac over 2a, that tells me how far to the left and to the right I got to go from the axis of symmetry to get to zeros, all right, where a graph crosses the x-axis. Now the big thing is, remember, that it must be written in standard form equal to 0. Completing the square, we have the constant on one side and the variable terms on the other, but when we're using the quadratic formula, we have to have it equal to 0 once again. Same as when we're graphing or factoring. So the first thing you should do when you're doing the quadratic formula is identify A, B, and C. All right, so you know which ones to plug in where. So we have 6x squared plus 5x minus 4. And so I'm going to start with identifying what A, what B, and what C are. So we get 6 for A, 5 for B, negative 4 for C. Now I just plug them in. All right, so I'm going to use this, my version. And so we just put in the A's for 6 for A, anywhere there's an A, 5 wherever there's a B, and negative 4 where there's a C. So x equals negative 5 over 2 times 6 plus or minus square root of 5 squared minus 4 times 6 times negative 4 all over 2 times 6. Then we just do the simplification. So x equals negative 5 over 12 plus or minus. And now we'll do what's underneath the radical. Calculate that. If you want to do it there. But the thing is, the one thing that I would do is always calculate this as one piece, not the square root, just what the number is underneath the square root, okay? So don't put the square root on your calculator, just put 5 squared minus 4 times 6 times negative 4. And we'll worry about the square root after that. All right, so we get the square root of 121 over 12. So the question is 121 a square? Okay, it is. So we get x equals negative 5/12 plus or minus 11 over 12. So we're going to do negative 5 plus 11 and negative 5 minus 11 over 12. So we get 6 over 12 and negative 16 over 12. All right, so let's go ahead and take your calculator, all right, and verify those two answers. All right, so graph 6x squared plus 5x minus 4, and then check to see that this is the two answers you get. And so once you graph it, just hit trace, type in 1/2, right, and it shows me that y equals 0. We can see that it's flashing there on the x-axis, right? And then type in negative 4/3. We should get the same thing then. Right. So we can utilize our calculator to verify, and that's something you can also check that if you're at home and you're working on, you can check it with Desmos, all right? Because it'll tell you those exact decimal numbers. All right, so let's do another one here then. All right, so remember the first thing here, we have x squared equals x plus 20. It's got to be equal to 0. Now the question is, should I move the x squared to the other side because it's by itself, or should I move the x and the 20? I personally would move the x and the 20 because I'd rather leave the x squared as a positive. All right, so I have that positive 1 there. But it really doesn't matter. Okay, it's completely up to you what you want to do or not. But I'm going to move the x and the 20. Now, before you go any further with this, all right, the first thing you should always look at them, and this is me, okay, is that I like to factor, all right? And if I can factor, I will. But I want you to look at this one right now, and because it can be factored, all right? So I want you to factor it first, write it off to the side somewhere, all right, what the factorization is. And so you should already know what the answers are going to be before you start, okay, in this situation. Right? We're still going to use the quadratic formula, but we're going to use the quadratic formula to verify the answer in this case. Okay, so we identify A, B, and C. We know by factoring and solving we would get -4 and 5, so we're going to verify that. Right. Now, here's where the biggest mistakes are made with the quadratic formula. And it's because of B being a negative number, we make mistakes inside the square root. Because what happens is people just put in here -1 squared. And then they type that in their calculator, -1 squared. And you guys all know, because we've done this, we've noticed the problems with it already, that produces -1, right? But if I square -1, I get +1. Okay? So you have to make sure, and this is why I put the 5 in parentheses in the first one we did, is so that I remember that the thing being squared, the whole thing is being squared. Right? So -4 times A times C. All right? So you have to remember that B is negative. When I square that, I get a positive number. All right, so x equals 1/2 plus or minus 9/2. So we get 10/2 and -8/2, which is -4 and 5. So for most students, they prefer to do the quadratic formula over completing the square. I am a bigger fan of completing the square than the quadratic formula. But if given the option, usually you will go to the quadratic formula just because it's easier, because all I have to do is plug in the numbers. Okay? Instead of, completing the square is a little bit more work, a little bit harder. So, all right. Now, once again, you could check your answer by graphing this. All right? We would graph what we've done here once we've moved it. But you don't. We verified it already by factoring, so you don't necessarily have to, but I would usually check my answer. Okay? All right, let's go on then. Okay, so do the quadratic formula here for this one. All right, so now we're going on. I know I didn't give you paper for all this one, so you might have to go to your notebook paper then. All right, I want you to do the quadratic formula of this one, and then we'll talk about using our calculator to estimate our answer to the nearest hundredth. All right, so we get this fraction here for the quadratic formula, so we want to get it to the nearest hundredth. So we go to our calculator, and -3 divided by 2 plus. Now, this is where, if you do it the way the book has, it's actually easier for you. Okay, and so I'm going to type it in my calculator both ways. Square root 37, and then you have to make sure you get out from under the fraction bar, divided by 2. Okay, there's the positive answer. Now, to get the negative answer, all I need to do, go back up here, hit enter, and go back and change this to a minus sign. All right, so there's my two answers. Okay. Now, if you do it the way the book sets it up, Then I'll just go ahead and make my fraction bar. -3 plus the square root of 37 over 2. Makes it a little easier to type it in there. Okay. And then the same thing, I can just go up to there and then go back and change that to a minus sign to get my second answer. So whichever method you do it in, so we want 1.54 and -5.54 or 4.54. And the thing to remember is that when I put these answers on my paper, that since they are an approximate, since they are approximate, I'm going to say that x is approximately 1.54 and -4.54. Make sure you use the approximate symbol when you're writing it as a decimal. Okay. Now, in our warm-up, we did this table here, right, and came up with this these solutions down here for numbers 1 and 2. What this is, the b squared minus 4ac, is called a discriminant. Right? It's a specific thing that at times all we really want to concern ourselves with a quadratic function is how many solutions are there. We aren't necessarily concerned about what they are, but we want to know how many they are, so I have an idea of what I'm looking for too when I'm going there. Right? And so this is called the discriminant, and it's formalized right here in this table. So it says, here we've got just what we wrote down. b squared minus 4ac is greater than 0. You have 2 real solutions. If it's equal to 0, we have 1 real solution. And if it's less than 0, we have no real solutions. And then we can see all of that from this other chart with the graphs. 2 solutions, it crosses the x-axis twice. b squared minus 4ac is positive. b squared minus 4ac is 0. It touches the x-axis once, right on the x-axis. Okay? So the vertex is actually the 0. And when there's no real solutions, because the discriminant is negative, the graph will be above the x-axis. All right, so I want you to do these 3 here. All right? Find b squared minus 4ac in all 3 of them to find out how many solutions there are. Actually, just do a and b. Just do a and b. We just want to know how many solutions there are, so we're just going to calculate b squared minus 4ac. When it asks us to find how many solutions there are, all we're doing is b squared minus 4ac. Looking for a positive number, a negative number, or 0. All right, one last problem, example then. Story problem. So we're going to use, so the height in feet of an object shot straight up with the initial velocity of v in feet per second is given by this formula. We've used this formula, okay? We haven't talked about it as in this manner, but we've been using it. Where c is the beginning height of the object above the ground. So v is the initial velocity, c is the initial height of the ground. So if we're trying to find the height of an object, we use this formula, -16t squared plus vt plus c. H is the height of the object. -16, that's our gravity in feet per second squared. V is the initial velocity in feet per second, right? So what it initially moves at. And c is the distance, or the height of the object is above the ground to start with. So here we'll look at this is the example right out of the book, and we'll look at that first of all. And we're actually going to use our calculator. We're not going to use the discriminant. They say, hey, just use the discriminant to do this, but you know what, we're going to graph it and find out instead. A weight 1 foot above the ground on a carnival strength test is shot straight up with an initial velocity of 35 feet per second. Question is, will it ring the bell at the top of the pole? Okay. So they give us the initial height, which is c. It starts 1 foot above the ground. And they tell us that the initial velocity is 35 feet per second. And here is the height we're trying to reach, 20 feet. So this is c, the initial height above the ground. This is v, our initial velocity. And we're trying to find h, which is it going to get to 20 feet? Right? So is Michael going to ring the bell when he goes and plays that game at the fair? So all we're going to do then is once we plug these in, so we've got 20 is our value for h, equals negative 16t squared plus 35t plus 1. Right, here's our equation. Negative 16, gravity, 35 is our initial velocity, and what is the height above the ground to start with? And all we need to do is plug that into our y equals and see, is it going to make it to 20 feet? Negative 16 squared plus 35x plus 1. Right? And where's the easiest spot to find this out at? Where should I go to? Where? A table. All right. All I have to do is go to the table. Right? And the big question is really, what's the vertex? Because if the vertex, the y value for the vertex, if it's at least 20, we know it's going to ring the bell. If the y value for the vertex, so the max, if the max is 20, it's going to ring the bell. If the max doesn't get to 20, it's not going to ring the bell. Right? So here we can see from the table that in 1 second, the thing is going to be 20 feet high. So yes, it does ring the bell. Right? Don't need to do any more than that. Now, if I wanted to do the graph to check it, when I go to my window, I want my y max to be above 20, so I'm going to go to 25. And in my y equals, I'm going to actually put 20 in y2. This way, I can see if they're going to intersect or not. All right? And so when I graph it, we can see that it just touches it. All right? Just touches it. So that will work. So we're just going to use our graph or table to check these out. All right. All right. So the question is, what if, suppose the weight is shot up with an initial velocity of 20 feet per second, will it ring the bell? Well, the answer is no. All right, because what happened at 35 feet per second? It barely rang the bell, right? So if I don't put as much force onto it, is it going to get anywhere near as high? Okay, probably not. So our new equation then is going to be that 20 equals, we're still at the height of 20 feet, negative 16t squared plus 20t, that's this number here. All right, and it still started 1 foot off the ground. So I can go to my y equals, change the 35 to 20, and go to the table or the graph, and we can see that, yeah, it doesn't even come close to making it. All right, so the first one must have been Michael, the second one must have been Scott, right? Okay, all right. All right, so we've gone through, the last of all the ways to solve quadratic equations. There's graphing. And this is the last thing in lesson 9. All right, talks about the different things, the advantages of graphing, advantages for factoring, using square roots, completing the square, and using the quadratic formula. Okay? Completing the square and quadratic formula always work. All right? Just depends on which one is your favorite when you get the option of which way you want to do it. All right? If I can factor, definitely prefer that. And like they say, good method to try first. Okay? When they say, hey, do it whichever way you want to do it. Okay? But usually it's up to you. And usually given the option, most of you go right to the quadratic formula because it's just a matter of plugging in the numbers and simplifying.